So we're really delighted this evening to be joined by David, who's been actively involved in nature conservation for 38 years. And in the Queen's Birthday Honours List in 2007, he was awarded an MBE for his services to wildlife, which he accepted on behalf of the Wildlife Conservation Charity, which he founded in 1988 and he still works for today. David began public speaking back in 1989 and over the years has spoken to an amazing number, which over 40,000 people, it says on your notes, David, here, so that's just incredible. So with the publication of the sixth mass extinction paper in 2017 and the IPCC's 1.5 degree report in 2018, David became increasingly concerned about our global situation and decided to create this presentation, which we're going to hear now. So David, I'll hand over to you.
Okay, thank you very much. I'm just going to try sharing my screen. Okay, so hopefully you can all see that. And hopefully you can all hear me okay?
Yep.
Okay, so we'll get underway. Actually, I've got four of you I can see down my right hand side of my screen, so I'm just going to minimize you. I can actually just see Nicola now. That's fine. So firstly, I have to say thank you very much indeed to Braunton Countryside Centre and 361 Community Energy for inviting me to give this presentation to you. In the slide, which I hope you can see, gives the title of the presentation, and you might be able to read, if you're not on a mobile device, you might be able to read the three, in the three lines, the middle one says, "Life seems pretty normal," in grey text. Hopefully you can all read that. Now, as I go through the presentation, you will realise that there is grey text, quite dark grey text on most of the slides, and you don't have to read it. The dark grey text is there for two reasons. One is to remind me what to say, and the other reason it's there is to tell you where the information that I'm giving you is actually coming from. It provides the source of the information. So I'm not going to tell you what's in this presentation. I'm just going to go straight into doing it. It always rather surprises me when speakers say, right, this is what I'm going to tell you, and then they tell you, and then they say, this is what I've just told you. I'm not going to do that. I'm just going to go straight into it. But first things first, I'll just tell you a little bit about me. In the picture here, I'm 1 year old, I think. It's photographed in 1959. I grew up in Teignmouth on the south coast of Devon. My parents moved there when I was a baby into a new bungalow. Both my parents were teachers. My dad was an amateur naturalist and a biology teacher at Dawlish Secondary Model School. Our bungalow where I grew up was mainly powered by fossil fuels. So we burned coal in the lounge. We had no central heating. In the kitchen we had a paraffin heater, and we had a thing called a gas poker for lighting the open coal fire, which I think was probably powered by coal gas. Of course, in those days there was no natural gas. The gas was made from coal. And so just in case you're listening from a long, long way away, I grew up in England, in the southwest of England in the UK. All right, and so I've been involved, as Nicola said, in nature conservation for a very long time, and my work was recognised when I accepted the MBE on behalf of the colleagues that I actually work with as part of a team. But one thing I should say at the outset is that I'm not a climate scientist. I don't have all the answers. So when we have the question session at the end, we may well find that I can't answer your question, but I could certainly tell you where I would go to get the answer to your question. So please bear in mind that this is not my main subject. Okay, so let's get going. First things first. Good planets are really, really hard to find. So in our universe, we've seen about 1 million billion planets. And out of those 1 million billion, we only know of one other planet that is potentially habitable with an atmosphere and with water. One other planet. And it rejoices in the name of K218b. And just in case you thought that if things here get too bad, you might go and live there, at the speed of light, it would take you 111 years to get there. So chances are you're not going to make it. So we really are completely dependent on one planet, which we call Earth. And isn't she beautiful? So in order to live on Earth, to continue living on Earth, what do we really need? Well, Earth is only habitable because it has a balanced climate system. And we can divide this climate system into different parts. One of the things that we definitely depend on is the presence of what's called multi-year ice and permafrost. So the obvious examples of multi-year ice are the frozen ice and snow at the north and south poles, but there's also, of course, massive areas of permafrost, particularly in the Arctic Circle, and of course, mountain glaciers as well. These massive areas of cold air and cold ground actually help to stabilize. They are, if you like, part of the air conditioning system for the whole planet. And without them, our planet would be unrecognizable. We are obviously dependent on fertile soils in the geosphere. Without fertile soils, nothing would grow. Without plants, we'd have no oxygen. So we're completely dependent on soil fertility. We're also dependent on what we would call the hydrosphere, or natural water cycles, the way that water moves around the planet. Not only water flowing around the oceans, we are dependent on that for reasons I won't go into, but also the way that water evaporates from the oceans, forms clouds and falls as rain. If we didn't have rain, of course, we'd have no soil fertility, etc. We're also completely dependent on the presence of healthy ecosystems, both on land and in the sea. And of course, we're dependent on the presence of our atmosphere. It needs to have a good balance of atmospheric gases, not only gases that are breathable, but also gases that help to insulate us from space, the space that Earth moves around in, which we're going to come on to look at in a bit. So think about it. Our climate depends on all those things. If we lost any of those, just any one of those, Earth would become uninhabitable. So what's all the fuss about? I mean, okay, we need all these things, but actually, you know, the Antarctic and the Arctic are still frozen, crops still grow, it still rains, you know, we still have lots of wildlife, there are still fish in the sea, and we can breathe, thank goodness. So what is all the fuss about? Well, unfortunately, if you look closely into any of these areas, you discover that we're losing ice on a massive scale, and that ice loss is accelerating. Crops do still grow, but actually crop failures for a variety of reasons, including drought, are increasing. It still rains, but droughts are increasing, and also extreme rainfall events, which can be troublesome, are increasing. We still have wildlife, but wildlife is in decline. It has been for many years, and that decline globally is accelerating. Yes, there are still fish in the sea, but fish stocks are low and declining. We can still breathe, but actually air pollution, for example, kills people, thousands of people every year. Why are these things happening? Well, let's look first of all at the climate crisis. The climate crisis is a lot to do with what's happened over millions of years with carbon. So life on Earth has existed for a long, long time, and lots of different populations of organisms have evolved and disappeared. And even those species that have survived, of course, lots of individuals have died over the years. So in many of the eras of life on Earth, much of that life was in swamps and in the oceans. And organisms that died tended to sink to the bottom. And over millions of years, more material was added, and those organisms fossilized. And the carbon contained in their bodies basically turned into carbon-rich fossils in the ground. And these days, we call those carbon-rich fossils natural gas, crude oil, and coal. There's also another kind of fossil originating from animal life and plant life, which is bitumen, or also referred to tar sands. You've probably heard of the tar sands in Alberta in Canada, for example, that are massive and being mined, open cast mined. When you look at this graphic, which I found on the internet, please don't assume that natural gas is always closer to the surface and coal is always further down in the ground. That's not the case at all. Sometimes it's quite the reverse. So collectively, we call these fossils fossil fuels because we pump them up or dig them up and we burn them. And when we burn those carbon-rich fossils, we release the carbon into the atmosphere as carbon dioxide. And that enhances something called the greenhouse effect. Now, we've been burning fossil fuels for a long, long time. The Industrial Revolution, based on the burning of coal, began in England in 1760. So this has been going on for a really, really long time. And I'd like to, for those of you that don't fully understand, I'd like to have a go at explaining to you what we mean by the greenhouse effect that is enhanced by the burning of our fossil fuels. What is the greenhouse effect? Well, we're very, very lucky on Earth that we have an atmosphere. If we didn't have an atmosphere around the Earth, the average global surface temperature would be minus 18 degrees centigrade. So of course, life as we know it just wouldn't exist. But fortunately, we have an atmosphere, and the atmosphere tends to work like a greenhouse, hence the term greenhouse effect. So what the atmosphere does with its various layers of gases is it traps some of the solar radiation which is re-radiated from the surface of the Earth. So the sun obviously heats up our planet and our atmosphere. The solar radiation comes through our atmosphere. It is reflected, some of it, by the surface of the planet, and some of the re-radiated heat is trapped by the upper gases. And the main greenhouse gases we're talking about here are carbon dioxide, which I mentioned already, but also methane and nitrous oxide. Okay, now when I first tried to understand this, I thought, well, this doesn't really make any sense, because if solar radiation can get in through the atmosphere, then how come it can't get back out to the same extent? And it's to do with the wavelength of the radiation. The solar radiation coming in is a shorter wavelength than the re-radiated heat, and the longer wavelength heat is trapped much more effectively than the shorter wavelength heat coming in from the sun. Okay, so we've enhanced the greenhouse effect by releasing this CO2, the carbon, into the atmosphere, and that's had the effect of raising the temperature. So the global average temperature was plus 14 degrees C, and now it's above 14 degrees C because we've increased the amount of CO2, which has trapped more of that re-radiated heat. So less heat is escaping out into space. Okay, so hopefully that's quite a simple explanation of actually quite a major and quite complicated thing. Okay, so the world's a bit warmer. A 1 degree average increase doesn't sound very much, does it? What does that actually mean? Well, the climate system is very, very sensitive. So you don't have to warm the planet very much before you get more storms. And storms have the effect of displacing people when they're severe. We get more floods for reasons that I will go into later. And this also tends to displace people and can affect our food production. And also, because of the increased amount of carbon dioxide in the atmosphere, the oceans have become more acidic, because basically some of that carbon dioxide is being absorbed. In fact, a lot of it is being absorbed by the oceans. And this turns into something called carbonic acid, which might sound a bit obscure and really nothing to do with you. But if you're a shellfish in the oceans trying to grow a shell, the last thing you need is for the ocean to be acidic. And of course, the ecosystems in the ocean, many of them involve shellfish. Also, because the world's a bit warmer, we have more droughts, which displaces people and reduces food production. We have more heat waves, which does a similar thing, kills people as well. And we have more wildfires, which kills people, unfortunately, sometimes, and also releases more CO2 into our atmosphere, making things worse. Okay, so the world's a bit warmer and it's having some of these effects. But how can you explain all the cold weather that we've had? I mean, that's very confusing for a lot of people. How can global warming produce colder weather? Well, to understand that, I need to introduce you to something you've probably heard of called the jet stream. And excuse me if you know and understand all this already. But for those of you that don't, the jet stream is a narrow band of very, very strong winds that blow around the earth, high up in the air. They're called the jet stream because they blow at about the same altitude as you would fly in a jet aircraft. So we're talking 35,000 feet perhaps, but they, in different parts of the planet, the height of the jet stream varies tremendously. But these winds at high altitude basically go round and round the planet. There's a similar jet stream in the southern hemisphere as well as the northern one. And they tend to separate the cold polar air from the warmer tropical air. And in the graphic, you can see that's represented by the pale blue and the darker blue. That separation and the fast rotation of the jet stream around the planet is driven by the temperature difference between the poles and the planet. Now, when we say that the planet has warmed by an average of 1 degree, unfortunately, it's not warmed evenly. The poles, in this case, the North Pole, has warmed more than twice as much as the global average. And so this has reduced the temperature difference between the pole and the tropics. And this has reduced the main driver for the jet stream. And the effect of that is that the jet stream is basically slowed down, and instead of rotating fairly smoothly and rapidly, has started to meander north and south. And sometimes those kind of loops, those bends in the jet stream can actually stop in one position and effectively block changes in major weather patterns down closer to ground level. So looking down now on Europe, here the jet stream is represented by this line of light brown arrows you can see. And again, you can see how it separated the warmer air from the colder polar air. And the whole thing, of course, tends to move from west to east. Our weather in the UK mostly comes from the west. But when it stops moving east, then you can have what we call a beast from the east, for example. So we can pull a lot of really cold air in from Eastern Europe or from the North Pole and have an extremely cold weather. The similar thing has happened in North America, even more extreme than we've had here in Northern Europe. And quite the reverse can happen. These meanders in the jet stream can pull the warm air a long way north. And last night, I added a new slide to this presentation. This was on the TV last night, this image. And again, it's showing you the separation between the tropical air and the cold polar air, with the yellow orange being the warmer air and the blue being the cold. Next time the BBC forecast shows you an image like this, rather than showing you the the normal weather map, have a look and just check what's happening in Greenland. If I can move my cursor, yeah, here's my cursor. So here's Greenland. Look how warm Greenland is. Greenland is warmer than the north of France, warmer than where I live. Look at Finland, probably across to Siberia. Did you hear in the news lately that Siberia just broke the record temperature for the Arctic Circle, recording 38 degrees inside the Arctic Circle? That record temperature has just been set. Yeah, so next time you're looking at our weather forecast and they show you this map, just have a look and see what's happening with Greenland. It often is very, very warm. And of course, Greenland, as you might know, has lost huge amounts of its ice. Okay, so that hopefully explains the cold weather we get and some of the heat waves we get because of the jet stream. But what about the floods? This year, we had a tremendously bad flood. At one time, we had 594 flood warnings in place in England at the same time. That had never happened before. This is extreme weather, and it's becoming more and more frequent. 93% of the energy that's been absorbed by the planet has gone into the oceans. Warm water evaporates faster than cold water, so the oceans are evaporating more water, going up to condensate and become visible clouds. And that means we get more powerful storms, we get more extreme rainfall and more floods, rainfall related floods. Of course, there are also coastal floods, which I'll talk about in a moment. Okay, so let's have a little recap. Loads of CO2 has gone up into the atmosphere. That's warmed the planet on average by about 1.1 degrees C, but the Arctic has warmed twice as much, which has changed the jet stream, which makes extreme weather more likely, which sometimes make the weather we get last for longer, and the sea is warmer, so we're likely to get more rain and more storms. And polar ice is melting, warm water expands, so the seas are rising. We'll talk more about that in a moment. Okay, so we all with me? You all got that so far. It's not that hard really to get your head around. But then, hang on a minute. I mean, CO2 levels in the atmosphere have always gone up and down, haven't they? I mean, have we really had that much effect? Well, we know from the ice core record. So people go to the poles of Greenland, for example, and then they drill down, they take out an ice core and they look at the little air bubbles in the ice, and they can work out what CO2 levels were doing in the past. Going right back in this graphic, going right back 800,000 years. And yes, indeed, you can see the wobbly red line there. CO2 levels have this natural variability between about 170 and 270 parts per million. What we've done in almost no time at all is we've increased that to 415 parts per million. 415. Wow. More recently, we've been measuring CO2 levels on a little island in the Pacific called Mauna Loa in the islands of Hawaii. And this measuring station was set up by a scientist by the name of Charles Keeling. And it's rather interesting for me because actually he started measuring the temperature there in the year I was born. As you can see in the graph there, it was 1958. And we've got very, very, very accurate readings of CO2 levels. Why did he do it in the middle of the Pacific? Well, of course, CO2 levels vary tremendously according to what's happening with vegetation. Vegetation takes in CO2, for example. And so if you want to measure it without lots of natural variation, you go somewhere very remote where there isn't lots of plant life. And also CO2 levels are affected by human pollution. So you go a long way from a lot of human pollution, hence Hawaii. But in this graph between 1958 2019, you can see how CO2 levels are going up, and the line is not straight. It's not a linear increase, it's a curved line. And a curved line, of course, means that the increase is getting faster and faster. It's accelerating. One of the things we've worked out, scientists have worked out, is that CO2 concentration doesn't go down on its own. If you look at the global temperature record and you look at the global sea level record, here in this graphic, we're going back 450,000 years, you can see that the three really vary together. And hundreds of very, very clever scientists have spent years trying to work out whether CO2 is driven by temperature change or whether temperature change is driven by CO2, and come to the conclusion that actually temperature change is driven by CO2 rather than the other way around. So because you can see on the right hand side there, because you can see we've raised CO2 levels, it kind of follows that temperatures are going to go up correspondingly and sea level is going to go up as well. Sea level increase is actually very, very predictable because there's a delay. So the sea level increase we're seeing today is not from the CO2 we released yesterday. It's from the CO2 we released years ago. And because we know with certainty what we've done with CO2 emissions, then we can know with pretty good certainty what's going to happen to sea levels in the foreseeable future. And I grew up in the town of Teignmouth, as I think I told you earlier, on the south coast of Devon. Here's Teignmouth. Well, in the next 30 years, half of my hometown is going to be flooded every year. My nearest big town is Newton Abbot, up the Tees estuary. Here we go, there's Newton Abbot. Half of Newton Abbot town centre is going to be flooded every year in the next 30 years. This is very, very dependable data, and it's not based on a worst case scenario for future CO2 emissions. I'm quite glad I don't live in West Somerset, because West Somerset is going to be inundated by sea flooding every year, more or less, within the next 30 years. And within that area is a nuclear power station at a place called Hinkley Point. And that is going to be completely surrounded by seawater within 30 years. And the powers that be in their wisdom are actually building another one in the same area. So sea level is going to have a huge impact. I should just qualify that though by saying that these maps, which you can look at for anywhere in the world, particularly important if you live in Holland or Bangladesh, these maps don't take account of two things. They don't take account of sea defences, which in some areas will reduce the flooding, and they don't take account of storm surges in sea level, which at times will make the flooding far, far worse. How do we know humans are to blame? You know, a lot of people will say, well, okay, CO2 levels have gone up and that, you know, it is unusual, but how do we know humans are to blame? Well, we've got really accurate data on the amount of CO2 that we've emitted and the amount of CO2 in the air. And if we look back at just the last 1,000 years, you can see in these graphs how similar the shape of those two lines are, which kind of suggests really strongly that it is the CO2 we've emitted which has caused the atmospheric level to go up. But there are several other lines of evidence, and one of these is to do with something called isotopic fingerprints. I'm going to get a little bit scientific on you now, but I came up with some wording for how to try and explain this in very, very simple terms. I'll just press that slide again. So some people claim that the extra CO2 in our atmosphere is natural. It's come from living plants or from the oceans, or perhaps it's come from volcanoes. But we know this can't be true because of carbon isotopes. So isotopes are atoms of the same element that have different numbers of neutrons. And there are 3 naturally occurring isotopes of carbon. Remember, it's carbon we're talking about with the CO2 and the fossil fuel burning. So these 3 naturally occurring isotopes of carbon are known as carbon-12, carbon-13, and carbon-14. Carbon-14 is very, very short-lived. You've probably heard of carbon dating that's used in archaeology. It's a similar kind of science. Carbon-14 is very, very short-lived, and so fossil fuels, which are very, very old, contain hardly any carbon-14, whereas CO2 from recent vegetation or the ocean is high in carbon-14. Now, since the Industrial Revolution, atmospheric CO2 has been going up, as you know, but atmospheric carbon-14 has been in rapid decline. So the additional atmospheric CO2 can't have come from recent vegetation or the ocean. And then there's the ratio in the atmosphere between carbon-12 and carbon-13. Plants, living plants, take up more carbon-12 than carbon-13. And carbon-13 is very, very stable and long-lived, unlike carbon-14. So carbon from organic matter, such as fossil fuels, is deficient in carbon-13. The decline in the carbon-13-12 ratio in the atmosphere since the Industrial Revolution shows that the additional CO2 in our atmosphere must have come from a source that was originally organic, such as fossil fuels. Now, if you take the information from both of those isotopes I've just described, the increase in CO2 can't have come from modern vegetation or the oceans because of the decrease in carbon-14. And it also can't have come from volcanoes because of the decrease in carbon-13, carbon-12 ratio. There's only one possible source that explains both trends, and that is the burning of fossil fuels. So there really is no doubt, these are just some of the evidence, okay? I'm not telling you all of the evidence, just some of it. There really is no doubt that it's our emissions that are the source of the increased CO2 in our atmosphere. So let's look at the effect of possible CO2 emissions in the next 80 years. Now, you've probably heard of scientists using things called computer models to try and work out what the effects are going to be. But of course, the effects depend on how much CO2 we're going to emit in the future, and nobody knows that. So in order to run their models, scientists create what they call representative concentration pathways, and then they can run their models using these different pathways. So they can say, for example, that if we followed RCP 8.5, which is that red line at the top of the graph, we would end up with a global average temperature increase in the range of 3.2 to 5.4 degrees C. And then there's a lower one, RCP 6, the bottom one, etc. So we've got a pretty good idea of what the temperature change will be based on these different future carbon emissions. RCP 8.5, leading to that very, very high amount of warming, is what's known as worst case scenario. We know from the fossil record, from future mass extinction events, we know that at that kind of temperature increase, most life on Earth would be wiped out. Perhaps half of all species would disappear. The others may not become extinct, but they would be drastically reduced in range and number. So that is really unthinkable, following that path with our emissions. Even the grey line you can see there, which is RCP 6, is enough, that kind of temperature increase, 2 to 3.7, that's enough to cause the probable collapse of civilization. Certainly life as we know it would be over. Humans, a few humans would survive, probably, but they certainly wouldn't be living the way that we're living now. Maybe we bring down our emissions from about 2040 onwards. See the yellow line there on the graph? That would basically mean we have more of the extreme impacts that we're already seeing. And the scientific community and a lot of politicians as well agree that where we need to be is on that blue line. We need to get ourselves into carbon neutral by the latter part of this century. That means we're actually hopefully going in below that black line, and we're starting to take CO2 out of the atmosphere rather than adding to it. That's where we need to be. But at the moment, that looks pretty unattainable. But we're trying. We are trying. You've probably heard of the Paris Agreement. Back in 2015, nearly all of the governments in the world got together and agreed to try to keep the temperature increase well below 2 degrees C. Hooray! That's absolutely fantastic. It was celebrated. But what have the countries in the Paris Agreement actually pledged to do? So here we are again with a similar graph, with the worst case scenario red line and the where we need to be blue line. And in the middle there, you can see that dotted line, which is basically what will happen to carbon emissions if all of the countries do what they said they were going to do in the Paris Agreement. The country pledges, as they're called, are at the moment far too weak to meet even the 2-degree target. It's a start, but it's nowhere near enough. Now the bad news. That is where we were heading this year, before the lockdown. We were fair and square on the red line. And that's not a good place to be. We know that that's with certainty that that's where we were heading, because we know how much carbon we emitted in 2018 and 2019. So basically, if we carry on as we are, life as we know it is over. That's why protesters are saying now. What is it that we actually need to do? Okay, so the IPCC, the Intergovernmental Panel on Climate Change, 3,750 of the world's best climate scientists are recommending that this is what we do with our emissions. From reaching that peak of 44 gigatons of CO2 per year this year, we drastically reduce our emissions to reach net zero by 2050. That's a reduction of 7.6% every year. That is massive. We've never had a reduction. We're not heading for a reduction, I think, in spite of the lockdown. And even if we do that, even if we follow that red line down and get to somewhere we hope would be safe, it would only give us a 50-50 chance of limiting warming to 1.5. And that's why protesters are saying 2050 is too late. So when our UK government claims that we are world leaders in tackling climate change and we're going to be carbon neutral by 2050, don't believe that that's enough. You know, if you knew a bus had a 50-50 chance of crashing, would you get on it? Unfortunately, the IPCC, 3,750 scientists, they do have a history of underestimation. When news stories come out about new environmental things, you know, such as major weather events, for example, the news is always worse, nearly always worse than the scientists expected, and hardly ever as expected or better than expected. For example, with the rise in sea level because of the ocean warming, principally warm water expands, the actual increase in sea level we've seen is much, much worse than was predicted by the scientists. And similarly with the loss of Arctic sea ice, much, much worse than was expected. So when you look at IPCC predictions, please don't think that that is worst case scenario. It's probably, it might be an understatement of what we're actually looking at. Okay, so changing the subject a little bit now, looking at climate change as a health issue. If we look at information coming out from the World Health Organization, we can see that when we talk about heat waves killing people, I mean, we're not making this up. Just one heat wave in one part of the world in 2003 killed 70,000 people. 70,000 people. The number of deaths we've seen globally from COVID-19 is just over 500,000 so far. Climate change already kills nearly twice as many people every year. Already. And the economic benefits, the money we'd save from improved health, are more than double the costs of cutting emissions. The economic benefits of improved health are more than double the costs of cutting emissions. So if we pay to cut the emissions, we would save twice that amount of money in improving our health. That's incredible. We face total disaster with the trajectory that we're on at the moment. And it is a massive challenge, and it's not helped by some people backing out of the Paris Agreement and trying to burn even more coal, the most polluting of the fossil fuels. Here in the UK, our government will sing our praises, their praises. They will tell you how well we're doing. We have cut our emissions, but actually that 44% was the easy bit. That was basically shutting down old coal-fired power stations. At the moment, we are not on track to meet any of our CO2 emissions targets. Not any of them. This is an interesting slide from a fantastic resource called the Exponential Roadmap, which you can go to their website. So the number of parties, the number of governments that have signed the Paris Agreement is 197. If we just go down a little bit, you can see that the number of countries on the right-hand side, the number of countries that actually have legislation or propose legislation to reach net zero by 2050, which remember only gives us a 50-50 chance, is only 8. The increase in carbon emissions in 2018 was 2.7%. Remember, it needs to go down by 7.6 every year. The years we have left until emissions need to peak for the world to stand a much better chance of reaching the 1.5 target, 0. We're out of time if we want to stand a chance, a reasonable chance.
The earth has warmed 1 degree, that's increased the level of the sea. Warming makes the sea expand, it rises up and floods the land. At 2 degrees you can kiss goodbye to Miami and Shanghai. There's 20 million people there, who has that many rooms to spare? By 3 degrees glaciers have gone, with less polar ice to reflect the sun. Refugees will then exceed 250 million. 1 degree, no surprise, half our coral reefs have died. Such a rich ecosystem, 500 million people depend on them. At 2 degrees, I tell no lie, lots more coral reefs are sure to die. Corals bleach to a ghostly white, it's happening almost overnight. By 3 degrees, they will all be dead, gone with the life they supported. They'll never ever grow again, you see, with rising ocean acidity. At 1 degree, land gets hot, though you might think that 1 is not a lot. Extremely hot days per year increase to 4 or 5. At 2 degrees, farmers struggle, food supply is really in a muddle. Extremely hot days per year average 27. By 3 degrees, the weather's gone mad. Food is scarce, things are looking bad. Extremely hot days per year will average 62. We've warmed the earth 1 degree, signs are here for everyone to see. We must make sure we don't hit a major tipping point. There is a risk we can detect of triggering a domino effect. If that occurs, there'll be no way of stopping climate change. If we don't act decisively to combat warming urgently, on our present trajectory, we're heading for 3.2.
Okay, so let's move on now and have a look at the ecological crisis. There's lots and lots of people on the planet. So at the moment, there's about 7.7 billion of us. There may be 11 billion in the next 80 years. We don't know. Certainly numbers are still going up. The impact of there being so many people on the earth is not so much to do with how many people there are. It's more to do with how some of those people choose to live. Exploding human consumption is the driving horse behind the planetary change that we are witnessing, as much as, or if not more than, sheer numbers of people. It's our consumption, particularly of natural resources. So more consumption means more food, which means more farming. And we've felled roughly half of all of the trees on the planet in clearing land, principally for farming. Think about where you live just for a moment. Where are you now? If the house you're in didn't exist, and if your area wasn't urban or suburban or farmed, what would be there? Chances are it would be a forest. And in the southwest of England, it would be a temperate rainforest. It's gone. We only have 10% tree cover. We've obliterated our forests in the UK, and of course it's going on all around the planet. We not only get rid of the forest to produce our food, but we also take food directly from the oceans. There are no fish stocks in the oceans which are underexploited. The last ones disappeared in 2003. By 2003, all of the fish stocks in the oceans were either fully exploited, overexploited, or crashed. So it's mainly due to habitat loss and degradation that we are now in an ecological crisis. And just look at the biomass of mammals and birds on Earth. Only 4% of the weight of mammals on Earth are wild mammals. Ourselves and our livestock dominate the mammal world. Similar situation with birds. 70% of the biomass of birds on the planet are our domestic poultry. Only 30% are wild. As a consequence of this domination and this destruction, currently up to 1 million species, wild species, face extinction. The current extinction rate is 10 to 100 times faster than the average of the past 10 million years. We know that because of the fossil record and past mass extinction events and the gradual disappearance of species in between those events. Agriculture has the largest impact, and the loss of species and habitats poses as much danger to life on Earth as climate change. The loss of species and habitats poses as much danger to life on Earth as climate change. So even if climate change wasn't happening, we're still up the creek. Blimey. So in the world of biodiversity, the equivalent of the IPCC is the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. And they published a massive report in 2019. And the bottom line basically was sustainability goals cannot be met by current trajectories. So basically, if we carry on the way we are, we cannot make life sustainable. Of course, unsustainable means will end. We need urgent and concerted transformative change. That's the same message really as is coming from the IPCC concerning climate change. What does Sir David say? We are in the middle of the 6th mass extinction event. We have been for years. We're wiping out species on Earth faster than I think has ever happened before. Save possibly for the impact of a massive asteroid that darkened the skies. That might have been a quicker change, I suppose, but the rate of loss of species now is 10 to 100 times faster than the natural average. So it's incredibly fast. And I don't think personally that we should concentrate on extinction. Extinction means there isn't a single one left. There's not a single individual of that species left. But that's not really important. What's important is functional extinction. And what I mean by that is, as a species loses its range where it's found is shrinking, then basically it's disappearing from most of the habitat where it should be, and it is already functionally extinct. It's not there. It's not performing its role in that ecosystem. So it's already extinct. Whether there's 100 left in the wild or 10 left in the zoo, it doesn't really matter. Functional extinction is the really important thing. Single species can make a huge difference to ecosystems. Just think about the wolves in Yellowstone Park. You know, that's a kind of classic example of how the absence of one species changes everything. The rate of this is phenomenal. Vertebrate animal populations have declined by more than half in the last 50 years, since my childhood. More than half. just going back to climate change for a minute, more than half of all the industrial CO2 that's ever been emitted in our entire history has happened in just the last 30 years. It's that curve. Remember the Keeling curve, the acceleration. It's so fast. Put these two crises together and what do you get? You get less polar ice, which accelerates global warming. It's a feedback loop. You've probably come across that term before. Less permafrost releases methane, more global warming. Less fresh water means less food for people. Less soil fertility means less food. Fewer invertebrates means less food for people. Fewer animals on Earth means less food for people. Less food for people is often the bottom line for many of these changes that we're seeing. Okay, so let's say you accept all that, but you're thinking, well, okay, you know, I accept that, fair enough, but why should Britain, little Britain, why should we take the lead? You know, go and talk to China. There are some really good reasons why Britain should take the lead. For example, the two companies that spend the most on lobbying against measures to tackle climate change are the two companies that are 40% British owned, BP and Shell. We are increasing, not reducing, our investment in fossil fuels. Increasing at a time like this. And actually, CO2 emissions are not that much lower than anybody else's. We're the 8th worst polluter in the world, out of countries with significant numbers of people. And I emit, you emit, people here on average emit only 13% less than typical people in China. It's not a lot of difference. And we started it. We started it. The Industrial Revolution, which is the root of this, began in England. So surely there is a really good case for why Britain should indeed take the lead. And actually think about all the stuff that surrounds you. Think about all the stuff you buy, you order online. How much of it says made in China or made in some other country? A lot of other countries are producing CO2 on our behalf. So much of our manufacturing for the stuff we buy has actually gone abroad. Surely nobody would knowingly cause a climate crisis. Nobody would, surely. So that begs the question, well, do people know? Have leaders known? It was way back in 1896 that a Swedish scientist called Svante Arrhenius, I hope that's how you pronounce his name, calculated that if we doubled atmospheric CO2, we'd increase the surface temperature of the planet by 5 to 6 degrees. Amazing. 1896. The term greenhouse effect isn't new. That's been around for more than 100 years. Exxon, one of the world's biggest, now joined with Mobil, ExxonMobil, one of the world's biggest oil companies, their own scientist way back in 1978 was telling them about the effects of fossil fuel burning on the atmosphere and on the planet, on the temperature. Governments of the world certainly knew about the dangers of fossil fuel burning way back in 1988, otherwise they wouldn't have formed the IPCC. Knowing that CO2 emissions cause climate change, knowing that, oil companies spend $200 million a year on lobbying against policies to tackle climate change. They're trying to stop us finding a solution, the oil companies. And the two worst offenders the two companies that are 40% British owned. The UK gives more to the fossil fuel industry than any member state of the EU. Right-wing groups in America spend a fortune on climate science denial, which I'm going to come on to talk about. World governments give the fossil fuel industry $5 trillion a year in subsidies. That's more than they spend on healthcare. World governments give more money to the fossil fuel industry than they spend on healthcare. Wow. All of that money buys a shed load of denial. And to win, all the denialists have to do is create doubt. That's all they have to do. Because if there's doubt in our minds that we're in this situation and that it's man-made, then we'll think, oh, maybe they're wrong. Maybe we don't need to worry. That's all they have to do to win, is create doubt. And it's so easy. And climate deniers are so high profile. I mean, here in the UK, we have some extremely high profile climate deniers who work behind the scenes to undermine efforts to deal with these global existential threats. Nigel Lawson. This chap, Christopher Monckton. Go to YouTube, if you can bear it, and type in climate change Christopher Monckton, and listen, if you can bear it, to one of his denialist presentations. Actually, in the UK, our scale of denial is relatively small. Denial was born in the USA. The scale of it there is just unbelievable. Fossil fuel money setting up institutes, think tanks, foundations, projects, and endless vocal people spouting climate science denial. It's huge. It's the biggest and most expensive disinformation campaign in human history. It's even bigger than the campaign that said smoking is good for you. Bigger than that one. Quite good, really, if you come up against people who use denialist arguments. It's quite good to have some kind of understanding of the techniques that they use. They may not realize they're using one of these techniques, but if you understand what they're saying, why they're saying it, what they're trying to do, it's much easier to deal with. One of the things they often do, remember, all they have to do is create doubt, is to set up a fake expert. So they basically say, you know, just put up anybody and say that you know, they know what they're talking about, and the climate crisis is all rubbish. And then somebody will create a TV program, you know, comparing what they're saying to a climate scientist, and they've won. That's all they have to do. Just create the illusion of an ongoing debate. And in an argument, another technique they'll often use is to throw in what we might call a red herring. So they'll throw in some random fact which really doesn't have much to do with what's being talked about, just to put everybody mentally off their train of thought, just to distract from the argument that the climate scientist might be winning. They might set unrealistic standards of proof and claim that the evidence is insufficient. And one of the most popular ones is cherry picking. So you remember that graph I showed you in the song of the ice loss in the Arctic going down. Of course, when a graph like that goes down, there are time periods when the ice is increasing. And cherry picking is basically just taking part of the data, not looking at the whole picture and saying, ha, there's no problem, the ice is actually increasing. That's very common. If a denialist is losing the argument, then the last resort is to say, ha, the scientists are all collaborating with each other, and it's all one big conspiracy. They're falsifying the evidence for their own ends. Whereas in reality, 97% consensus amongst scientists in the natural sciences is absolutely unprecedented. Well, as far as I know, it's unheard of. I mean, in other sciences, like for example in physics or chemistry, you can repeat the same experiment in the same circumstances and always get precisely the same result. So there you would get 100% agreement. But in the natural sciences, you're never going to get 100% agreement. To get 97% consensus amongst publishing climate scientists that humans are causing global warming is phenomenal. I mean, that really is the gold standard in terms of, proving something beyond doubt in the natural sciences. 97% consensus. Denial is very, very understandable. We tend to look at denial as black or white. People either believe or they're in denial. But actually, some people say that we're all in denial. If we weren't all to some extent in denial, then how could we get out of bed in the morning? How could we start our car? How could we feed our child something produced by intensive farming that destroys wildlife? Maybe we're all in denial to different extents. It's very, very understandable. Don't feel bad. Just get over it. The science is absolutely clear. We know what we're facing. Okay, what to expect if we do nothing?
If global temperatures rise by 2 degrees Celsius, the chances of avoiding a 3-degree increase are slim, and here's why. Warmer seas absorb less carbon dioxide, so more accumulates in the atmosphere. This adds to the global warming which caused the rising temperatures in the first place. Nowhere is affected more than the Amazon. Scientists say a 2-degree rise will kill off up to 40% of the rainforest. Huge amounts of carbon are stored in the soil, around double the amount already in the atmosphere. Warmer soil means dead vegetation rots more quickly and more carbon is released. At a 3-degree increase, plants stop absorbing CO2. Enough carbon builds in the atmosphere to raise temperatures another 1.5 degrees by 2100. The planet is tipped into runaway global warming. In this future, hurricanes are much stronger. Cities in Asia, Australia and the southeast United States face destruction. As snow disappears from mountains, cities and farms around the world lose their rivers and reservoirs run dry. Saltwater creeps upstream and groundwater is poisoned. This tips food production into an irreversible decline. Grain yields decline by 10% for every degree above 30 degrees Celsius. As the land dries up, seas continue to rise. All low-lying areas suffer floods, and the Netherlands is torn apart by the North Sea. 3 million years ago, when temperatures were last in this range, there were no continental glaciers in the northern hemisphere. Trees grew in the Arctic, and sea levels were 25 meters higher.
What we need now, what we really need now, are solutions. My God, we need them. Just thinking about the carbon, okay, where's it coming from? Industry, transport, energy, food. Those are the big sectors. So those are the things we need to think about. Just thinking first about energy. If you consider all the sectors, energy use is responsible for about 2/3 of all the emissions. So it's the biggest sector. And power generation alone accounts for around 40%. Energy solutions. Okay, what do we need to do? Well, we live in a democracy, thank goodness. We have representatives who are making decisions on our behalf about our laws, about our financial incentives, our policies. And hopefully they're doing the right thing. Now, luckily for us in this country, we have a website where it's very, very easy to check what your MP is doing, whether they are making the right votes, the right decisions in the House of Parliament. You just go to that website, put in your postcode, you go to the subject area like environment, climate, and it'll tell you the decisions that your MP is making. If he or she continues to support fossil fuels or fails to support renewable energy, then of course you are free to lobby them, phone, write, visit, camp, protest, and ultimately, if they continue to make the wrong decisions, vote for somebody else. Try and get other people to vote for somebody else. In terms of what you can personally do, use less energy. Switch your electricity supplier to one that is 100% renewable. It's very easy to do. Hopefully you've all done it already. Stop using fossil fuels as quickly as you possibly can and switch to the alternatives. Okay, it's not rocket science, is it? You know, there's lots of alternatives these days. Personally, we've just purchased our first electric vehicle. Join or start a local community energy group. And of course, we need to remember Community Energy 361 is one of the hosts of this presentation, and that's exactly what they are, a local community energy group. So join one. If you live in North Devon, join them. If you live somewhere else, join another one or start your own. Transport. Okay, so transport is huge as well. 73% of transport emissions come from short journeys. 73%. So what do? Check what your MP is doing. Okay, if they continue to support fossil fuel powered transport or fail to support the switch to renewables, then obviously you're going to lobby them or you're going to get rid of them. Personally, what are you going to do? You're going to avoid flying in a jet unless you have absolutely no choice. Just don't do it. Stop buying diesel and petrol as quickly as possible. Use public transport, car share, walk, cycle. You know the answers probably already. Yeah, and travel less. So you haven't gone out to listen to this presentation. You didn't start your diesel car. You listened to it online. So you've already saved some emissions. Fantastic. Food. So food production is the largest thing driving the sixth mass extinction event that we were talking about earlier, and accounts for almost a quarter of all emissions. Okay, so food is a pretty big one. Food solutions. What's the first thing you're going to do? You can probably guess. Check what your MP is doing. It's so easy to check whether they're making the right decisions. If they continue to support intensive farming, which is bad for the environment, if they fail to support wildlife, afforestation, and the move to plant-based diets, then lobby them, get rid of them. Personally, what are you going to do? Ideally, you're going to eat a lot less meat and switch to a plant-rich diet. If you become a vegetarian, that's going to reduce your own food emissions by up to 63%, 70% if you become a vegan. Eat local, eat organic, grow your own, eat food that's in season, hopefully reducing food miles, don't waste food, and compost more, etc., etc. Consumerism. Again, a huge sector. Only buy what you really need. And hopefully with the lockdown, you've actually had a little go at this. You haven't been out buying things. You have managed to go without things, at least for a while. Only buy what you really need. Don't buy fashion goods. The fashion industry is terrible for the environment. Don't buy new things unless you really have to. So the electric car that I've just got, my first one, I'm delighted with it. It's secondhand. It's fine. Choose sustainably produced, locally made, fair trade, stuff that can be repaired rather than thrown away. Avoid plastics and plastic packaging. That's a slightly different subject, but still relevant to what's happening to biodiversity. Reuse stuff, rehome stuff, recycle stuff. You've probably heard it all before. Voting. There is a danger that you assume that your MP is making the right decisions. Just look at the track record of voting on measures to tackle climate change. Okay, this is public record. This is fact. It's irrefutable. The blue dots are Conservatives. They have a terrible track record when it comes to voting on measures to tackle climate change. So it is particularly unfortunate that we vote for Conservative governments. If we can't change to a different kind of government, then what we need to do is change the minds of the Conservatives, if there's time. Do not assume that your MP is doing the right thing. That's why I say check the decisions they're making on your behalf. And the last solution, talk about it. One of the problems with these major issues is that people don't talk about them enough. Talk to your neighbour, talk to a friend, talk about the weather. We love talking about the weather, don't we? But talk about an extreme weather event. Why did it happen? Your first-hand experience of climate change. Okay, if you found something that you can see is related to climate change, just tell other people about it. The wildlife you don't see anymore. When did you last hear a nightingale singing in England? Wildlife decline is all around you. If you're worried about something, share your concerns with other people. Talk about this presentation. Talk about anything to do with the environment, just to help to raise awareness. If you've made a positive change to reduce your impact on the natural world, talk about that with other people. You know, if they can see that somebody else has already made a positive change, that's very, very encouraging. Okay, what to expect if we do it all? So if we do all of that and other things, you know, if we remove all our investments from fossil fuel banks, don't bank with Barclays, you know, they give £60 billion to the fossil fuel industry. If we move all our savings into ethical banking, and if the governments do all of the stuff we've talked about, all the things they're supposed to do, if we do all that, what we'll have is more time. I really think that that is probably the best that we can hope for in the situation that we're in. That's more time to adapt, more time with our families. And if we make those changes, we'll also feel better and we'll have stronger communities, thinking about our dietary changes and our local support, like our energy groups and what have you. We'll have stronger communities and we'll actually have better health if we reduce pollution in the atmosphere from driving cars, for example. We will feel better. The alternative to the solutions is nothing. If you want to witness all of those terrible things, surely you don't, but if you did, all you have to do is nothing. Just carry on as normal. That's all you have to do, and it will all come to pass. So now you know. Now you know what all the fuss is about. This is an emergency. Time is not on our side. We can, we've proved it, we can change our behavior when we perceive that something is an emergency. Just think for a moment about the lockdown. We transformed our behavior almost overnight. We kept the jets on the ground. We didn't go out in our cars because we perceived something was an emergency. The climate crisis and the ecological crisis are an emergency. We are out of time. We've got to change now. We are dependent on one planet. We're all in the same boat. We need to help each other, support each other. There is still hope. There is just about still time to act. Surely this is worth saving. We must do everything we can. We must act now for life and for the children. Thank you very much for listening. And in the chat, which you can get to on the side of your screen, you should find the links to 2 sources of further information that I've created for you. So yeah, once again, thank you very much indeed for listening.
Thank you very much, David. If you just want to stop your screen share, lovely, thank you. Okay, well, there's some pretty stark warnings for us there. But some hope at the end that if we all pull together and we start to make the changes and we can get the policy changes in place, that we can make a difference. So has anyone got a question that they'd like to ask David, please?
Probably not.
Into silence.
I
Okay.
think they're all in shock.
Oh, Mary's got one for you. I'll just unmute you, Mary.
Thank you. Hello, David.
Hi.
Hello, hello. Just one thing I thought might give us a little bit of hope. There's been news of drastic reduction in the world population recently. How much will that help?
Okay, yeah, I think that one must have passed me by. I didn't know that there had been a drastic decline.
No, not that. Sorry, there's going to be. There's going to be. It's
Okay.
going down. It's going down.
So I think
Okay.
Mary's referring to, there was a bit of news the other day that like future populations are dropping because people are having less children. So in the future, the population rise might not be as much as it was first predicted.
Okay, yeah, so that's great. I think based on our track record of what we've already done to the planet, you know, if we carry on with 6 or 7 billion people on the planet, I think we're still going to be in the same situation. But if it's not going to go above 7.7 or 8, then so much the better. But I don't think that's going to get us out of our situation on its own. We have to think about, we have to think about the way we live. It's our consumption and our destruction that is the problem, perhaps a little more than our numbers.
Yes, I think you're absolutely right, David. That's what they were saying, is that although the population's going down and people are having less children, that people are getting obviously richer and they're still consuming more. So even, you know, if you're from a poorer country and you've got a bigger family, you might actually be producing a lot less CO2 per capita compared to, you know, a smaller family from the Western world, say. So I think, you know, it's kind of seems like it might be good news, but also, you know, still a lot to do in terms of reducing our emissions overall. Is anyone else? And another Mary, the other Mary has got a question.
Do I read it? Yeah. Unfortunately, the way the media put it across the news about the population, they put it across almost as bad news, not good news, because of there'll be the temporary blip in imbalance of, you know, with generations and not enough young people to look after and pay for things, and that was the disappointing bit, you know. So it was almost like the media, you know, they were wanting a solution. In other words, they weren't one. It was frustrating to hear that slant from the media, you know. And just one thing, if I can also just say, yeah, the thing I have a bit of a problem with sometimes when it comes to the diet and you know, obviously us, you know, eating less meat, which probably is important for a lot of people, but when it comes to sort of ecology and, you know, habitats, that especially living in North Devon, where, you know, we don't have, you know, a landscape and fields that it would be good from a biodiversity point of view for those to be turned over to arable farming. You know, we grow good sort of beef and natural lamb in North Devon. And it's, you know, and I know some farmers that are actually quite conservation minded, I think, are sometimes worried about this. And, you know, it's something that, yeah, it's not, you know, we have to have a at balance. But I don't think in this country, in some countries where, yeah, they're taking down, you know, rainforests, more beef, and such as in South America. But here it's, you know, it's a tricky one, really.
Yes. Okay. Thank you, Mary. I mean, it's rather tricky for us when we complain about other countries doing what we've done. You know, we protest about the rainforest being cleared for cattle, but we've done the same to our own forest. We, you know, our landscape should be temperate rainforest. And I know full well about you know, quite a lot anyway, about farmland wildlife, and I know particularly about the wildlife associated with unimproved or semi-improved grassland, which is needs cattle to maintain it. And I'm sure there are lots of arguments you can make. It's rather like the game people will say, you know, we need the shooting industry because it provides habitat for wildlife with the field margins of millet or quinoa or whatever that are growing there. You know, we can make arguments to try and maintain the status quo, but actually, is the status quo something that we really want to maintain when we know for sure that it is at the root of our problems, the way that we treat the planet? So rather than imagining those fields of flowers and cows going to rack and ruin, imagine them becoming permaculture allotments. You know, it doesn't have to be a bad change. And one of the obstacles to that obviously is our system of private land ownership. But I think, you know, farmers respond to demand. And if demand for meat goes down, then, you know, changes will surely come. And the Committee on Climate Change for our UK government are saying all the right things about the changes in land management that we need to see. We just need to work out how to apply it on the ground. But thank you very much, Mary, for your question.
Thank you, Mary. Claire's got a question. Need to unmute you. You'll have to unmute yourself, Claire. That's it.
Have I done it?
Yeah, that's it.
I just have a question about a lot of the things that we describe that we should be doing in order to reduce our carbon footprint as individuals. And the same with the plastics. So I work within the plastics industry, work for Plastics Free North Devon, and I always feel like these things are really focused on individuals in the sense, and a lot of them aren't, like the playing field isn't level. So when you talk about electric cars or transferring your energy to something like to, you know, solar or whatever, and then cutting your diesel and your petrol and using less plastic and stopping fast fashion, these are all things that I feel like aren't accessible for everyone. And I'm feeling the same within the industry that I work in as well. I'm getting this real sense of hitting my head against a brick wall, because I feel like everyone that has maybe the privilege to be able to do those things are already doing it. But until we put things in place to actually make these sorts of things accessible to everyone, and make, you know, going into a supermarket and being able to access refills that are as cheap as stuff that's wrapped in plastic, and being able to buy organic, locally sourced meat in the supermarket if people want to buy it, are the only way that we're going to get everyone on board. And I just wondered if you had any advice for trying to encourage that kind of legislative and that kind of holistic lobbying, I suppose, because as well, like with the plastics, when you were talking about it, you said it's a slightly different topic, but actually plastics set to quadruple by 2050. Obviously less of the fossil fuels coming out of the ground are going to be used for cars and maybe fuel, and a lot of that is going to be funneled into the plastics industry and that production. Yeah, I'm just kind of slightly concerned. I almost think that we almost need to be making those connections more, because actually plastic is it's a daily reminder of the kind of this horrendous system that functions behind it. And I'm asking for advice really, because I'm at a bit of at the end of my tether in terms of where to go next.
Okay. So yeah, I mean, bear in mind that this subject is not my principal field. I'm probably not the best person to advise you on such a broad-ranging topic.
Sorry.
No, that's fine. Don't apologize. I mean, I put myself forward as a speaker and I say that I'll take questions, so I have to do my best. There are some really useful links in the two links, the handouts that I created, which hopefully are the hyperlinks are in the chat. I would strongly suggest you go to those. And also, I think it is difficult for people in poverty. You know, poverty is not something that's limited to the third world. I mean, we have poverty right here in Devon, and it's very difficult for people who are really struggling to make the right environmental choices. And there are always going to be people that we don't get through to, who can't afford to spend 50% more buying organic, and that's just a sad fact. I think we have to not let that stop us, and we have to carry on. I mean, I'm not a wealthy person by any stretch of the imagination, but I made getting rid of my diesel car a priority, and I bought a second-hand electric car, and I'm absolutely loving it. And there are a lot of people around who are more wealthy than me, who are driving fossil fuel powered vehicles and haven't switched their electricity supplier to one that's renewable, and probably not, you know, doing other things like I don't know, harmful things with plastics perhaps. So yeah, I mean, there will be people who can't afford to make the right choice for the environment, but there are a huge amount of people who can. Look at the average house price now in Devon or in England, £320,000. I mean, anybody who can afford a house can surely afford to switch their supplier to green energy or ecotricity, for example. And the other thing I would say is that we don't have time to educate everyone. Educating everyone to solve this problem through consumers making the right choice would take years and years and years. Environmental education is fantastic. I do it. I believe in it. I'm not saying don't do it, but I'm saying we're out of time. We've been doing environmental education for 30, 40 years, and now we actually need our leaders to see the big picture and make the right decisions on our behalf. We can't wait for everybody to understand. We can't wait to win all the arguments and get everybody to change their habits. We don't have time for that anymore. So whilst I'm not belittling your work, you know, when I see wildlife that's been killed by plastics, I thank God for people who go up and down the beaches and talk to people about plastics. That is wonderful work. And I'm going to carry on my work in nature conservation, which involves education. I'm not saying stop. I'm saying, as well as that, we've got to shake the Houses of Parliament and say, look, you're our leaders, you know the science, for God's sake, make the right decisions.
Claire, actually, I'll just jump in on the end of what David was saying. There is actually a policy think tank. It's called Contraction and Convergence. I don't know if you've ever come across it before. It's a very famous environmental policymaker called Mayor Hillman, and he talks about it's basically effectively like carbon trading. So we'd all effectively get an amount of carbon credits that, say, if you wanted to fly to your holiday in Australia, then you'd have to buy extra credits from somebody who hasn't used theirs up. So it would be a much more equitable and fairer way of dealing with carbon, which means, you know, we could actually effectively drag some people out of poverty. So, yeah, look into that. It's very interesting.
Can you put a link on the chat as well?
I'll have to look it up, but yeah. Otherwise, I'll send an email round to everybody tomorrow with David's links as well, so we can have a look into that. But yeah, that's a really big policy driver that you know could instantly change things.
I was going to say, because almost it seems like the people that are slightly maybe have more money tend to be able to make more sustainable decisions and maybe shop plastic free or maybe change their electricity supply, but they also seem to be the people that maybe travel a lot further and buy more things. Yeah,
they'll definitely have a bigger carbon footprint, so it's a much more equitable way to do things.
Oh, okay, yeah, now have a look at that. Thank you.
Thank you, Claire. Stephen's got a question for us. I'll just unmute you. Hi, Stephen.
I've done it. Okay, hello everyone. Hello, David.
Hello.
Yeah, no, fascinating. I could keep you here for another hour discussing and asking questions, but that would be very, very tedious for everybody else. First of all, yeah, I don't know. I just love this concept that most of us are just middle-class hypocrites, and myself included. And we really do need to be incredibly careful, worrying so much about what everybody else is doing, and that we really need to look inwardly and make sure that there's so many things we can do that aren't actually a huge hit on us. So you've just bought your electric car and you've taken a big hit in your pocket. So that's obviously a big tick. The fact that we just recycle a little bit of our plastic and we may buy some locally sourced beef, it's very easy to do lots of little tick boxes that don't actually have a very big effect and think that we've been very, very pious. So, I mean, that's a bit of a hobby horse of mine, but fairly or otherwise, I don't know. But a slightly more challenging question for you is, would you not be making a bigger difference if you went down the dreaded political route? Now, you came here and advised me about barn owls, and I have the most stunning rich wildflower meadow coming on now, full of butterflies, pouring out, insects coming out of every corner. No barn owls, but you know, that's not the end of the world. But yeah, it's interesting. Where do you think, I mean, that presentation was stunning. How are you going to make the biggest difference with the rest of the time you have on this planet?
Well, that is a challenging question. I'm not interested in, I am interested in politics, but I'm not interested at all in being a politician. So I hope that I can have a quite a big impact by giving presentations. It certainly helps me to feel better, helps me to feel that I'm doing something, but it's just the beginning. I mean, you have to bear in mind the first one I ever gave was just before Christmas. I did about 9 before the lockdown, and I've done 2 on Zoom. So I'm only just at the beginning of this, and I'm hoping that it's going to get through to more and more people. But in terms of what else I can do, yeah, I mean, I've been doing nature conservation for many years, and what we've always tried to do with our single species conservation is to get a broader message across to people. But I've got to the point now where I really believe that everything that we've been doing for the last 30-40 years is not the answer. I'm not saying we should stop, but I'm saying if it was going to work, it would have worked by now. And we're running out of time. So I do go to London, I do protest. I am prepared to stand on the front line of the protest to kind of make my point. I think, I mean, I don't see myself as a leader, but if that sets an example that other people want to follow, you know, there are thousands and thousands of activists now. Yeah, that's what we need. As I said before, we need to rattle Parliament and actually get the politicians to stop thinking about the next election and start thinking further ahead. You know, I think if you're managing a garden, you can probably think a year ahead, a vegetable garden maybe. If you're managing a farm, you're probably thinking 4 years ahead. If you're managing a country, you probably need to think 30, 40 years ahead. If you're managing a planet, you need to be thinking 500, 1,000 years ahead. And they're only thinking about the next election. I really believe that most of them are not far enough sighted. So yeah, anyway, I think I've probably failed to answer your question. But asking me how I think I can be most effective is very challenging. And I may yet come up with a different idea.
Well, you made a fantastic start, and I would dearly love to recommend your presentation, depending on how often you're prepared to give it, but to as many people as I can, because it's not an eye opener, but it's a fantastic and succinct summary of such an important issue. Okay. So, I mean, you had a big influence on me when you talked about barn owls, and now I'm quoting you every time I take someone around my field. So perhaps this is going to be a bigger step forward if I start quoting today's talk.
Yeah, so as I said before, I would encourage you to do that, to talk about, talk about the wildlife you don't see anymore, talk about what you've done to increase wildlife. That's very encouraging for other people. So yeah, I forgot what the other thing was I was going to say, but yeah, I mean, you're doing a wonderful thing there. Oh, the other thing I was going to say is that I created this presentation, but I don't want to own it. So what I'm doing is I'm sending it to other people to present. I just sent it to somebody to present in Bangladesh, and I sent it to somebody else to present in Belgium. And any of you that want to present it, I'll send it to you and you can do it yourself. And if you don't want to present it, the other thing you could do is go to the Facebook page, which has the same title as the talk, and just leave a review or a comment to encourage other people. That would be great.
Will do. Thank you very much.
Thank you, Stephen. Well, you definitely get my vote, that's for sure, David. So Trudy's got a question for you. I'll just unmute you, Trudy. You might have to unmute yourself. It's saying ask to unmute. That's it.
Yeah, I've unmuted. It's not a question really, it's just a comment. And I think that talk needs to be on prime time television, because I think it's really accessible. I think it's really clear for the general public. It's one of the best and clearest talks on this subject that I've heard, and I've heard an awful lot. So I think, approach the BBC and say, look, here's our offering. Show it on BBC One at 8 o'clock. Please.
That's a remarkable idea, which I'm sure will never happen. But thank you very much for the compliments. And yeah, so it's obviously nice for me for people to say stuff like that. But actually, in reality, I think we all have to do our bit. And this is just something I can do. And you can go out and talk to people about it. Just use the ideas that I've given you. There's a fantastic, I think the author is Dr. Rini Letzman. There's a fantastic YouTube video called How to Talk About Climate Change, which is only 3 minutes long. There's a link to it in one of the handouts that I provided in the chat. And absolutely brilliant. Tells you how to broach the subject with anybody, really. Yeah, best of luck to you. Thank you very much.
Thank you. I do what you suggest, and I know Renee Letzman as well. So, but I just think this, approach the BBC, ask them. Good luck. Thank you. Thank you so much.
Okay.
Fantastic. Thank you, Trudy. Has anyone else got a question or a comment they'd like to raise?
I think we've probably all had enough.
Well, that was absolutely fantastic evening. Thank you very much, David. So what I'll do tomorrow is that I will email everybody and I'll send the links from David, and I'll put those links in about switching and the things that Claire discussed as well. So just a quick note. So we do have a talk coming up next week with Adam Reeve, and he's going to be doing seashore foraging. Adam is from the Ramblers Pantry, so we're looking forward to that. So please do come along to that and sign up for that. And also, if you're in North Devon on Sunday the 2nd of August and Sunday the 9th of August, we've got 2 guided walks organised with Pete Yo, who's the Nature Connections Guide. And he's actually going to be one of the things that he discusses on his walk, which is about future flora. So he does discuss about the impacts of climate change in the future. So I just wanted to say a thank you as well to everybody who made a donation tonight to the talk. So thank you all for coming along as well. And finally, could you all join me in a big virtual hand clap or thumbs up for David, whose talk is absolutely amazing and inspiring. And I'm sure we're going to be going out there now and discussing it with our mates down the pub. Thank you very much, David. Thank you.
Thank you. Thank you very much indeed.
Have a good evening, everybody. Thank you.